Hi, I'm Pat. All right, they've given us this f of x, which you can recognize as a rational function. It's a fraction with a polynomial up top and a polynomial downstairs. What they're asking of us is to find all asymptotes and wholes of this rational function. So here we go. I would probably start with your horizontal asymptote, okay? In order to find the horizontal asymptote, what you want to remember is that you're looking at the degrees, the degree of the top. And by degree of a polynomial, we're talking about that highest power. So in this problem, that degree of the top is 2. But that's just one piece of information. What we want to do with that is compare it to the degree of the bottom. Again, the bottom is a polynomial, and you're looking at the power of the highest powered term downstairs, which is also 2. So for this problem, the degree of the top equals the degree of the bottom because 2 equals 2. Okay. Now, when the degree of the top equals the degree of the bottom, like we have in this case, then your horizontal asymptote will equal as a y. Y equals, because it's a horizontal line, it'll always equal the ratio of the coefficients. So the coefficient, the leading coefficient up top is just 1. And the leading coefficient downstairs is this 2. So y equals the half is my horizontal asymptote. Okay? All right, next I think I'd like to move on to the vertical asymptotes. The vertical asymptotes we're going to be able to find when the denominator would be 0. So where the rational function is undefined. But there's a little bit more to it than that. Here's the next thing I would do. Say, don't want to just grab that denominator and set it equal to 0 and find out where the function might be undefined. But because before I want to do that, I want to go ahead and do some algebra. I mean, wouldn't you? You want to do some algebra where what we do is factor. Factor the top, factor the bottom. So each of these is a nice quadratic trinomial, which factors pretty friendly, I think, each one of them. X minus 4, x plus 1. And then the denominator, 2x, x. And I think we're getting a 1 and a 1 plus and minus. Double checking by foiling, but that looks good. Okay, now, the reason we did that, though, is because notice that there is this factor of x plus 1, top and bottom, that would divide out. Okay, so this simplified version of our rational function is just x minus 4 over 2x minus 1. And we would have a little like x not equal to negative 1 because of that crossout we did. But here's the real point. This simplified version of your function is where you want to look for your vertical asymptotes. Now you want to grab this denominator, 2x minus 1. Set that equal to 0. And this is again where I was saying earlier is that what we're worried about is the denominator equaling 0, where the function would be undefined. But through these few steps, it's a matter of the simplified version of your function being undefined. So just grab that denominator, set it equal to 0, and we get x equals 1/2. And I'll circle these if you want, just so you know. These are like answers for us in terms of y equals 1/2 is your horizontal asymptote, x equals 1/2 is your vertical asymptote. So what about the factoring that we did and the crossing out that we did and the simplified version with that little x not equal to? This is where your wholes come in. Is when you have a value of x that makes both the numerator and the denominator 0. That suggests a whole. It tells you that there's a whole. So this x equals negative 1 is a whole for us. X equals negative 1. Okay? So whenever we have the crossouts, you want to figure out what it takes for that expression that you crossed out to equal 0. Okay? That value of x is going to be a whole if there's a crossout top and bottom. Okay? And one last step then is let's also figure out the y value for that whole. The y value, we're just going to take that x of -1 in this case and plug it back into, let's use this simplified version. Okay, if you went any higher, you'd get 0 divided by 0. So let's plug the -1 for x into this simplified version. -1 minus 4, 2 times -1 minus 1. A little bit of arithmetic, minus 5 over minus 3, which equals 5/3. Let me slip over here if I can. So the whole has coordinates of -1, 5/3 as an ordered pair. In fact, another circle there for your answer. Okay? Hope that helped. You got to practice these, okay? Horizontal, vertical, and then look for these holes too. Horizontal, asymptote, vertical, asymptote, look for the holes. All right, try some on your own.